Okay, we're going to talk about hemostasis. Hemostasis of the blood involves three phases: vascular phase, platelet phase, and coagulation phase, which stops bleeding in damaged blood vessels. During the vascular phase, at the injury site of the blood vessel, here you see a knife going through the blood vessel, a vascular spasm occurs, which constricts the vessel. This allows blood leaving the blood vessel to slow or even stop and can last up to 30 minutes. The endothelial cells contract and divide, which allow them to become sticky so platelets can adhere to them and to other endothelial cells. Here you see the vascular spasm. In the platelet phase, it begins as soon as the platelets attach to the endothelial cells at the end of the vascular phase. Here you see the platelets attaching to the endothelial cells. Platelets also attach to the basement membrane to expose collagen fibers and to other platelets. Chemicals are released: ADP, calcium ions, platelet-derived growth factors, and clot factors, and allow for combining of platelets from the bloodstream, vascular spasm, clotting, and help in repairing the tissue damage. A plug may form in the injured site. Here you see the platelet plug. The coagulation phase begins about 30 seconds after damage occurs. Coagulation occurs only if certain clotting factors are in place, factors which include calcium and 11 different proteins. The extrinsic pathway will begin when factor 3 is released from damaged tissue and activated platelets. It then binds with calcium and factor 7, which is produced in the liver and requires vitamin K, to form a tissue factor complex strong enough to activate factor 10. This also requires vitamin K as well. The intrinsic pathway begins when factor 12 and activated proenzymes are activated by exposed collagen fibers at the injury site. PF3 is released by the grouped platelets at the injury site. PF3 combines with calcium, which activates clotting factors 8 and 9. These two factors make it possible for a tissue factor 10 complex to activate, which then activates factor 10. This also does require the liver, and it requires vitamin K as well. The common pathway will begin when either the extrinsic pathway or the intrinsic pathway activates factor 10. It then forms prothrombinase. Prothrombinase converts prothrombin into thrombin. The clotting process is completed when thrombin converts into fibrinogen, and fibrinogen converts into fibrin. Platelets and blood cells stick to the fibrin. The platelets squeeze and contract the clot, and it goes through clot retraction. This is where the injured site becomes closed together, and the clot and the clot comes down underneath the injured site. The platelets squeeze and contract, and the clot goes through clot retraction. The clot retraction will make the injury site smaller, and it secures the injury site.